Oh, cool.
Okay, so it's the Ortelius Thanksgiving architecture meeting, and we're going to go back to Sasha, who was talking about his Ortelius in the box.
Yeah. So all the containers come up very nicely now, and I see they're all node ports. And my ingress controller deploys perfectly, and it's using my local IP address of my machine as the external IP. So it's functioning as a load balancer. I see you created a ingress, which is cool, and it's listening on. I think it's like a wildcard, right? It just listens on for anything on port
Um,
80.
yeah, what I had to do on that front, um, so let me share my screen here if I can find share. So one of the things I had to do is because we still have the monolith, the so this is the monolith repo that we're looking at in Visual Studio.
Mm,
And in there's the backend Tomcat server that serves up the Java code, like the JSPs,
mm,
and it runs a bunch of the monolithic Java queries. So this
mm-hmm,
guy connects directly to the database.
mm-hmm,
The UI is supposed to be more of the UI front end stuff, so all the JavaScript, HTML pages and stuff like that. It was an attempt to kind of separate the front end from the back end, and then the Nginx part is where we have um, the service. So the service is pretty simple. Um, right now, yeah, there it goes. So the service basically is going to come up on 80. And if we look at the deployment, we're having the images come up on 80. So what ends up happening is the Tomcat server will come up on port 80,
mm-hmm.
and we'll kind of do stuff on that front there. So actually, if you look at the deployment for the service here. So this is one of the 80 the Tomcat service, and so that's coming up on 80, and then like I said, the Nginx is coming up on 80, and the Nginx container that we use is doing what's called a reverse proxy.
Mm-hmm.
So the reverse proxy piece is mapping the front end traffic to the back end pieces accordingly.
Okay, I
And
understand.
I'll show you that in a second. So if we go back to the
Your
ingress,
mm,
um,
your your Nginx is your front end really, and
well, we
talking.
actually have like two front ends.
Yeah, so it's like
So,
your front end, which is serving your back end, directing to the. Yeah, okay, okay,
yeah.
okay.
So
That's clever.
this is what I added yesterday.
Mm,
Was this section here to do an ingress. And the missing part that I needed
yes,
was this
the
class
class
name.
name. Yeah,
And this is if you do if we do a
I was just going to ask you. I had to. I was like going to ask you. Do I need a class name for the Nginx controller?
yeah. So what you end up doing is um what is it? Image class name. Oh, ingress class name. There it is. So the ingress class, um, what ends up happening is this I think is installed by default when the cluster is built originally.
Mm,
And so
it's
this
part of
gives
your
us,
controller. Your Ingress controller wants it.
yeah.
Mm,
So Kubernetes, this is like the default Kubernetes one
okay.
that we're able to connect to.
Mm,
So that's where I was missing the class name here. And basically it would the ingress would come up, but it didn't know how to route anything.
Mm.
And so that was one thing I had to change on that. And then also I had to add the host back in.
Ah.
And the reason why I had to add the host back in is because when I deployed to our Azure cluster, I couldn't use a wildcard asterisk
Yeah.
because we have the docs and the website are also ingresses. And one of the weird
Uh,
things that if you look at the ingress, so the weird thing when I deployed over to our Azure cluster, this is the ingress that we're just looking at in the YAML file, and then these are the two other ingresses, and they all came up on the same
same IP.
IP address. So I couldn't use a wildcard here because that would capture all traffic to go into that one.
Yeah.
So I actually had to do a host name there.
Okay,
As
well, that makes sense. And then you direct it as per host name for your ingress.
yeah.
Yeah, that's smart. Yeah.
Now the other thing that we have in the ingress on the other side is this top part. The ALB is the Amazon load balancer. So I've deployed over to
Oh,
EKS.
oh, have you put Ortelius in EKS? Nice.
I have Deploy Hub running. One of our customers is running on AWS.
Okay, cool.
So, and they wanted to use the Amazon load balancer. So we needed to add in a bunch of annotations
Makes sense.
about how to connect to the AWS load balancer. Now, what we should do is add in GKE and
Mm, mm,
whatever other ones we need to do
mm.
on the ingress side. So
Yeah.
that's what I've been finding is the ingress is where all this weird cloud native stuff is coming into play.
So the load
Where
balancer is looking for these annotations so it understands what to do, right, with the traffic,
Yeah,
right? Yeah.
exactly. And that's where you set up your SSL routing and redirects and things like that. So, like on this line here, the load balancer will automatically redirect all traffic that's going to 80 over to
Mm,
443.
mm.
So basically, the way we with Ortelius, we do everything. All the certificates are at the load balancer level,
Mm.
and not at. We don't do SSL traffic between all the pods.
Okay.
Um, it we could do it. It's just a headache with all the certificates and stuff like that. And for what we have, it just wasn't worth the effort to try to get certificates in place. And I've tried to use like Let's Encrypt and things like that, and it just falls
Mm.
over. It just doesn't. It
It causes a lot of overhead that you really don't need, eh?
Yeah. So kind of the diagram. Let me.
So internally in the cluster, the pods can talk to each other, sort of there, right? There's no
Yeah.
encryption inside, and
Yeah.
people like all go, oh, security. But I'm like, if someone's gotten that far into your network, I think you've got more problems than
Yeah.
pod security.
Yeah. Exactly. So one of the things that we did um, when you started working on this project was um,
Did I cause you
the
some headaches?
no, you just forced me to clean some stuff up. And the main thing was the we use a JWT token to so once you log in, the login returns a JWT token that has your user ID in it and a date.
Mm,
Basically, it's a UUID, so we know that it's basically like a unique session ID. So in that JWT token, encrypted in that is your user ID and the UUID.
okay.
And what that allows us to do is after the login is finished, we save that as a cookie, and then every transaction going back to the server pushes that cookie across. Now, if we go to one of the microservices, we want to make sure that the microservice is validating that you're a real user and just not somebody hacking the system. So that's where that validate user comes in at the beginning of all the microservices. That validate user pulls the cookie and then decrypts the token, gets your user ID and the UUID, goes and looks up your basically in the database to see if you've been authenticated before. And then if you've been authenticated, it just updates the timestamp to kind of like a keep alive timestamp. And it'll return a success or failure at that point. And then if you fail user validation, then you just get kicked back. If you are successful, then you actually get to go into the microservice transaction at that level. So that's how the things are kind of pulling together. So we actually have the front end load balancer, which is going to point to the Nginx ingress, which then points to the Nginx reverse proxy.
That makes sense.
And then this guy goes off to the backend services. So service one, service two, etc. So that's kind of how the networking comes into play. And like I said, where'd it go? This class that we're looking at, the Nginx class, gave us that default initial load balancer route. So I think and this is what you should be seeing on your side, is that we have the ingress should give you a public IP address that then you could use your little DNS tool to map over to that IP address.
I've actually found a tool that's even easier and there's no setup.
Oh, cool.
It's called local.gd, and it's a guy that set up a DNS in Netlify that always points to your 127. It's very smart, right? So the only thing a developer would have to do is add the name, create their own. I'll put it in the README, but they just have to create host names in their host file using that domain, and it'll always resolve to there. And using make search, you can make your own SSL certs, and you can test out your application.
Perfect. Cool.
Perfect. Yeah.
Yeah, because this level here doesn't have the default ingress doesn't have SSL enabled, but if we use like one of the cloud providers ingresses, then we get the whole SSL level. So if we need to get fancier, we may need to add some more annotations or something to the default ingress.
So my idea, I don't know if you think it's a good one, is just to use whatever the person's local IP is as their external. And that's what they would use to go into their Kubernetes cluster on their local machine. Yeah,
I think that'll work. Like you said, it's the networking pieces get a little weird, whether you're using Minikube versus Kind versus stuff like that. But I think if we can figure out Kind seems to be a lighter weight and more popular than Minikube.
I like Kind because it resembles an actual Kubernetes cluster that you would encounter in the cloud environments. So it's a like for like environment, and that's something that developers or students would be able to learn very quickly, right? They'd be able to get the feel of Kubernetes like it would be in the cloud. So that's why I chose Kind too. And also because, like you said, it's much lighter. I mean, you can't just do something like on, what was that other one you just said? No,
Minikube.
Minikube enable ingress, and it'll just do it for you. Now you actually have to understand it, right? So it's a bit more. It's maybe a little bit more learning, but you won't have to do it if it's all automated. But it's like encountering the real thing, right? Which
Yeah.
is what you want, really.
Now on this part, the Nginx reverse proxy, you'll see here I went into another folder that has our entry point Nginx, and this is basically all the configuration files for this reverse proxy. Now,
cool.
you'll see that there's like 3 or 4 of them, 4 different files. And based on the values that you pass into your Nginx, you'll see things in there like SSL off, different options. And what that's doing is setting environment variables to let us know what configuration files we need to kind of copy over to start working with. Because, you could we can pass in certificates to the SSL, to the Nginx, and have you can skip this ingress technically, and you could go from the front end right to the reverse proxy, and that's the way I used to do it before you started playing with Kind, and we recognized that we needed an ingress. But what ends up happening is the way the reverse proxy works is this is where we set up just things like how to handle the transactions, what you're going to zip up to make things faster. And then you'll see that there's these upstreams.
Nice. Yeah,
and these are actually the name of the, right here is the internal DNS name for that service. So this one is bringing up the MS General service on the default namespace on port 8080. And we associate that to this this MS General backend. And you'll see here's the other, like the validate user microservice. This one's a little interesting because the same service understands how to do, it's the same URL path that needs to handle a post and a get, so we had to do some special stuff there. So you'll see all this stuff happens at that level, and then we have our listening pieces. Listening on 80, and this is like if we're going to use keys, this assumes that we're going to have an SSL. Let me look at this one; it'll be a little more cleaner. So this is the one that we're currently using that we just deployed, is the backend services, and we're just listening on port 80. You'll see this statement here, the location, and this is where you actually do all of the routing. So when we get in this URL path, so this is one of the location files. When you get this URL path coming in, you're going to capture that and you're going to route it over to the specific upstream. Let me look at another one here. So like in this case, we have the API endpoint, and it's going to get routed over to the backend at this point. If we look at like the get applications or get all domains, that's the URL, and then it gets routed over to the backend again. So there's a bunch of them. For every single transaction, there's a location file. And some of them, like I said, handle, like here's the text file one. This is one of the microservices. And it's going to go to a different.
Oh, it's a lot of config, man.
I generate these, so it's not.
Okay.
You'll see that there's a script out here that basically what I did was I took them and created a little Perl script that read this and spit out the all these files for me. I didn't feel like typing them in.
Jeez, I don't blame you. I wouldn't want to either. That's amazing.
And then like here's like there's the home page. This is going to the front end the UI microservice or monolithic piece. And here you can see that we had to handle multiple paths. So if you wanted to load up the CSS, the JavaScript, all those URLs, the images we have to capture and make sure that we have the routing correctly. So that's how this is all kind of plumbed together. So we have the front end, which will be, like you said, either the cloud provider or the default Kubernetes load balancer, or just the ingress. It just depends on how we get that configured. But the ingress will give us our external IP address, and then we push all the traffic to the reverse proxy, and then the reverse proxy splits it out between all of the different services.
Yeah, well, that makes sense.
So Nginx is really powerful because
it's amazing.
You could do so much stuff with it, like here we're overriding headers and things like that. You get to do a bunch of fun things with the Nginx configuration.
Yeah, it's super it's super workable, right? You can do whatever you want with it.
Yep. So at the end of the day, like you said, and this was one of the things that we had to change, was originally the Nginx was coming up as a load balancer. And that was because we didn't have the ingress. And then when we changed it over to an ingress, we had to change it over to a node port.
Yeah. So now the ingress controller in the Kubernetes cluster, which has that external exposed load balanced IP, should route to that one, right?
Yep.
And then that one would route to all the others, right?
Yep. So this ingress here, so if we
and then you're splitting it up by using your host names, which is like a super smart way to do it.
Yeah, I had to, because we have multiple things running in the same namespace.
Yeah, it's the simplest way to have solved that issue. Yeah. I think pathing would have caused you a lot of extra work.
Yeah, it was difficult, put it that way. So this is the ingress, and you'll see that when this host name comes in, so it's going to match that on that host name, and then it's going to take anything that starts with a slash, which is basically everything. It's going to push it over to the MS Nginx service that's running on the back end.
Makes sense.
So
and that'll have the class. Will that won't have the class? Is it? Is it the ingress? Oh yeah.
I don't recall. Yeah, this has the class. This is going to be. I don't know if it shows it here.
Oh, okay.
Yeah, I don't see it showing the class that it was that you're talking. I know what you're talking about. The class name here.
Yeah, that. Yeah.
I don't know why it's not showing it. Maybe just the way it, when you do describe, it just doesn't give us enough details.
Yeah, because I also got confused. There's Nginx for Kubernetes by Nginx themselves, F5, the company.
Yep.
Then there's an Nginx ingress controller, which is maintained by the Kubernetes community.
Yep.
So you can get really confused. And what I chose was, in the end, I went for the one by the community, because I just felt like that one was the closest to Kubernetes, because it's Kubernetes community. So that's the one I chose.
Yep. Now, the weird thing I can't figure out, so this is the public IP address, and then you have your routing, and this is going to go to the back end, but the back end is coming up on 1.72. And if you look at the cluster IP for the node port, it is different.
It's totally different, yeah. So how's it?
And I don't know. I haven't had a chance to figure out, like you said, the the routing inside of the networking side of Kubernetes can be a little strange.
Yeah, I must say it's something that I really need to. It's taking me. I need to understand it better. That's why I'm glad I'm doing this. But yeah, there's some confusing things in there which I'm like, how does this thing work?
Yeah, and I don't know how or where this internal IP address is coming from. If I have a feeling it is a node, what is it? Get nodes.
Mm. And if you do a wide, can you get more information like on that ingress? Does it give you more information if you do an output
Oh,
equals wide?
what was it? Format equals wide.
I think I just use -O. Or you can do it that way, I think, yeah. -O equals W, I think. A small O, yeah. Small O equals W, I think. Is it that? No. Oh, is it wide? And I can't remember.
Oh, I'm gonna double dash. No, it may not be on for describe.
Maybe. Oh, for describe, yeah. I think it only works on a get.
Yeah. So I think if we describe the node pool, let's see if it has. So there is, that's the UMask basically for the node pool. So that's what it's routing to, is to the node itself.
Okay, Q proxy is doing all the
So
the plumbing.
This ingress, this IP address is to one of the actual nodes, it looks like. Or something like that. So I think because it's a node port, it's going over to that way.
Yeah, makes sense.
Like you said, the internal routing can be confusing.
Yeah. Yeah, because sometimes I've been looking at it, I'm like, how does this thing even talk to itself? Talk to the other components?
Yeah.
Yeah, the networking piece is quite challenging.
So we're gonna one quick question. This is gonna totally jump topics. On the XRPL, there's like I think 2 or 3 issues that a couple people have taken up, but they haven't actually done any work on them. It doesn't look like. Does it make sense for me to just place a comment in those issues to see if they're still working on them and try to get a response? Because they're kind of holding us up. Or should we just kind of take them over and just not give them the option? What are your thoughts?
When's your deadline?
I think we can create more stories, and since we want few of these stories to be completed soon, right? We can assign it to people who are active.
Yeah. Okay. So yeah, if it's like it has to do with like the transform on the SBOM data with what's happening in the IPFS, the NFT storage. And there's another one with loading the license data into a.
That is done. That is completed.
Okay, cool. All right, perfect.
PR is done. Yeah.
All right. So I'll go ahead and create some more stories. There is a gentleman from Ukraine. I think it goes by Nick. NIK is his handle, I think on Discord. But he does some UI design. So I'm going to create a couple issues out there around UI design to see what he can come up with ideas for kind of reworking some of the tables and searching capabilities that we're going to need to use. Kind of be able to map out what a like a list of components and a list of applications, and then the other part is a time series piece. And I know Utkarsh, you did some work on the time series at an application level, and I think I want to build off of that. Remember with like the 3D chart thing?
Yeah, that would work, but if we can get some more, materialistic design, then that would make more better UI, right?
Yeah. So that's what I'm gonna get some issues out there, work on those, and try to flush that out so everybody has a good idea, a good idea of the direction that we're headed with the UI, and make sure that the data is going to be easy to navigate, because I have a feeling we're going to have a lot of data, and that's always a challenge when you got a web browser front end, is making sure that you just don't sit there and get the kill page message because it's taken so long.
Correct. We already have a lot of data in the test blockchain ledger.
Yeah, so, I know. It's amazing how quickly it grows.
Yeah.
All right. Well, let me update those issues and create some new ones. Does anybody else have anything that I may be missing for today?
No, not from me. Just thanks again
Arvin,
for
you got anything? You good?
Awesome tweaking on the Ortelius side.
Yeah.
Arvin, are you gonna learn Terraform as well from Sasha?
Mm-hmm. He is. Teach him.
Yeah.
Cool.
Then we will learn Pulumi.
Yeah, I wouldn't worry with Pulumi right now. Just get Terraform, because Terraform is cloud agnostic. Okay, so it's Pulumi, but Terraform's free. I think there's a bit of a paid story with Pulumi, I've heard, but I'd have to investigate that closer.
Yeah, I got to learn Terraform as well. I have it for another project. I got to.
I can give you guys 2 tools. If you get to a client and they already have a cloud infrastructure which they've been deploying, okay, there's these 2 tools you can use. One of them, they both do the same thing. I don't know which one. I just found them. What they do is because it's very easy to set up, and what they will do is, if the people aren't using IAC yet, these 2 tools will actually convert their entire cloud infrastructure into Terraform code for you. It'll do 70% of the work for you.
Oh, perfect.
So yeah, so if you've got a client where they've got cloud, but they haven't been deploying it in an infrastructure as code, model.
Yeah.
Obviously it makes sense to use infrastructure as code because of all the benefits of, tracking changes and config drift and all that. We'll just take this tool. It's open source. I'll put them in the channel for you guys now, and it'll literally suck in the entire cloud infrastructure.
Oh, perfect.
And make Terraform and write the Terraform for you, and all you'll have to do is just go and push out the hard-coded values, right? And turn it into something more dynamic. That's all.
Cool. Oh, one last thing that I saw. So one of the things I did to get everything kind of hooked back together is I removed the Google Cloud build and moved everything over to GitHub Actions, and you'll see that I reworked the so this is the monolith repo, and what it does is it'll let me get to the right branch. I hate when it does that. Okay. So I did a build push chart. Basically what I've changed everything to do is we'll go through and does our login to Quay. We do our build, our Docker build. We generate the SBOM, and then we go and take the information and we push it into the charts. And one of the things that will, like it says, like chart version actually comes from the GitHub run number. And the image version comes, so we calculate those at the beginning. So what ends up happening in the monolith, everything ends up having the same chart version and image tag, but they go to their different repos. One of the things I try to do is parallelize, make this run in parallel, but this chart and releaser got confused when things were being updated at different times with commits and things like that. So, but basically what ends up happening is we go through and build everything, create our new chart, and then we go off and trigger another workflow that's in another repo. And that workflow then runs a Node.js that Ben from down in Australia put together. So what we'll do is the JavaScript will take all the repos and go find the latest version of the chart, and it will go through and generate a new chart for us. And you'll see here we have the charts, and I check them in, so every time we know what's happening. So this is the latest chart, so 49. So if you're looking, Sasha, to find like the latest one, just go over this repo and open up the chart, and it'll have the latest version number in it for you. And you'll see that it went out and found like the dep package microservices at version 2, where like the scorecard is at version 43. So each one of the microservices, when they build, they go off, create their local chart, and then they call that trigger to run the trigger back on this main one. So at the end of the day, what we have is our GitHub pages. And on the GitHub pages, we'll have all of our releases that are out there. Because one of the things that the Helm chart releaser does is when you have the parent-child type of chart, it'll suck them all into one big tar file. So this contains not only the parent chart, but all the subcharts are pulled together into this release. So it makes it handy for us to be able to have the different versions. And then the index.yaml, which is what the artifact hub uses, is updated. So you'll see here just another rendering of the parent-child charts. And that's going to be version 49. But then we go into what was in version 48, for example. So we kind of have a running history of all the changes as at the chart level. So Sasha, it just simplifies everything on your side to be able to just hit the one chart place. And then this is mirrored over on Artifact Hub.
Exactly. I've just been going to Artifact Hub and I've actually just been downloading the whole tar file and just unpacking it on my machine. And then all I do is just overwrite get rid of the old stuff and just dump the new one in. That's as easy as that. Yeah.
So all you have to do on that is you can set up your repo and just a Helm repo add. And then you could do a Helm pull.
Okay, that's cool.
Ortelius dash version 10.0.49 dash on tar.
Oh, that's very nice.
Now I should have that does everything that you've been doing in one command.
Thanks for that. That's a much better way of doing things.
Yeah. So when you said you're going over here and you're starting,
no,
but
it's not a good idea.
Yeah. Basically, you do a Helm repo add, give it the repository location, and then just make sure you do a Helm update.
Okay. To get the changes, right?
Yeah, because if not, you have a static snapshot.
Okay.
So that's an extra trick if you want the charts locally. Otherwise, you can just refer to you can do the deployments without having the charts locally.
Yeah, it's true. I could actually. Just in the beginning when I was doing testing and changing values and things, I had them locally. But for the dev for the Ortelius in the box, you won't need to. I don't think you'll need to have them locally, actually.
Yeah, the only values that we have are the database password and
that
where
I set that in Terraform to do that for you, so it does it for you. Yeah.
Then this one theoretically can come from, it's stored as a Kubernetes secret, so you can actually get the value as a secret to go find it. So you could do some like pre-processing to go grab the password if you wanted to. And then this is where the database is running. So this one is we're setting the host name where it exists, and it's running in a the service name is Postgres PostgreSQL in the Postgres namespace, and that gives us that internal connection automatically. This came up. This worked really nice because Postgres isn't exposed to the public. It's only exposed to the nodes in the cluster.
Yeah, it makes sense. It's nice. It's nice and secure in that sense.
Yep. So if you go into a different namespace, if you put Postgres in the Ortelius namespace, then you have to change that value there.
Okay. I need to change that. So okay. So it's Postgres dot. Is that Postgres?
So this is
service cluster namespace. Oh, otherwise it's running in its own namespace. Does it?
Yeah, Postgres. Okay. When Brad brought up Postgres on the Azure cluster, it was running in its own namespace, and I just reused it.
Oh, okay. Thanks for telling me that. I didn't realize. I didn't realize it. So, and what's the idea behind that? Is it better to have it outside in its own namespace?
It was just the Helm chart. So he ran the Bitnami Postgres Helm chart.
Oh, okay. Because I thought it would be nice to have that particular service running within the other components, right? They're all in the same cluster, in the same namespace. Sorry.
Yep.
Yeah. Okay, I need to go and change that then. I'll just change it. The Terraform can do that. That's easy.
Yeah, basically, if you want to do two like deployments, one for Postgres, get that up and running, and then do a second one for Ortelius. That may be the easier way to go. And the reason why I'm thinking that is if somebody is going to use like a managed Postgres, like on AWS or something, that's external to Kubernetes, then you can just point them to the Terraform for Ortelius.
Yeah, so for our developers, I was going to just deploy pgadmin as a container in the cluster, and you can use pgadmin to manipulate the Postgres database.
Yep.
So through a GUI.
If you go back to
then here, you don't have to worry about trying to command line everything with Postgres.
Right.
So at the moment, I've got set name as postgres.service.cluster.local. So what should it actually be? Should it be PostgreSQL.Ortelius?
Yeah. If your service is running in the in the same namespace.
Yeah.
Here it is.
If you prefer me to keep it the same as your production, then I should just keep it the same. I don't mind.
Doesn't matter. So here's the Postgres.
Oh, so you just use those templates. Yeah, it makes sense.
And this has this. I don't know what the default namespace is, but this is where you can set, like, if you want to know. It has a tons of parameters, but I think you can get away with just doing something real. Just take the defaults and see what happens.
Yeah, so what I've been doing with the Terraform, so when developers or people start using it, is that I've been using obviously comments to say, hey, this is Ortelius, and this is where it comes from, and this is the backstage one, and this is the captain one, and with the links in so the documentation is kind of also in the code.
Yep.
Yeah.
Perfect. So yeah, this is I think this may be the one that Brad used. It could have been this one, or there's a I just saw it. This one, the high availability one. I think this is the one that we have installed in Azure.
PostgreSQL HA. Okay. And it's the Bitnami one, right?
Yep.
Okay. See, there's an Azure one, actually.
Yeah, so this is where if you ran this Helm chart, you set the password. Back over on our side, we'd have to set the password here as well. So it's going to be the same password between the two.
It's very easy with the Terraform to do that during the deployment when Terraform runs. Yeah.
Now, the one thing I could do, Sasha, to make things easier is we could do a default in the values file.
That's clever.
To default it to postgres.ortelius.svc.cluster.local. So we can assume that everybody's going to come up in the Ortelius namespace with Postgres included, and then you just skip this whole parameter altogether.
Okay. Yeah. If I mean, I also don't want to create extra work. I just want to make it as simple for both sides of the the production and the dev.
Yeah.
But a values is easy, right? I mean, it's just a default.
Oh, yeah. All we have to do. Yeah.
Then it gives you lots of flexibility, right?
Yeah, exactly. So this Helm is not creating that Postgres, or is it creating?
This Helm is not creating Postgres. It is being created. It has to be exist before we get to this point.
Okay, that is a prerequisite.
Yeah, that's a prerequisite, exactly. So theoretically, we could do this.
So the Captain Lifecycle Toolkit doesn't have a Helm chart. You have to apply it from the YAMLs.
Okay.
But that's easy with Terraform too, because I just run kubectl inside the Terraform to do that.
Interesting. Well, we could always create a Helm chart for them.
Yeah. So we could create our own one, exactly. But it works. It deploys.
So we could do something like that.
We're actually really close now to releasing this thing, actually. I just want to be able to understand hitting the Ortelius front page, right? Making sure that works.
Yeah.
Because the most important thing is having Ortelius running. And then obviously once that's running, we can start working on the pieces that Utkarsh and everyone else needs for, well, I guess it's just Utkarsh and yourself. All the NFT stuff. Getting Arango up and running.
Yes. Yeah. We will need that Arango in there. And I'm guessing Arango would be a similar type of setup where is Arango? Yeah. How do we connect Arango over the network?
Exactly. And I've got Arango deploying already. It's cool. They've got a kubectl, a Kubernetes. It's an operator. Is that right? Yeah.
Yeah.
It's called a Kube Arango DB, and I haven't played with it at all yet to see if it's working, but it's deploying. So yeah.
So.
And then I'll write up the documentation.
Yep. So now with this being a default, once I check this in, we'll have the default for the DB host talking over to it. So you don't have to pass in. You can skip one more parameter.
Oh, that's great. Yeah.
And
Right.
are
This
you
looks
yes, Auburn?
this looks so cool, but it is a little bit hard for me.
No, I think what I would like to do, if you guys have got the time, and Steve too, is we have a session like we're having now, and then I say, look, this is what I've done, this is how it works, and then by doing that, you guys will give great feedback and suggestions, right, to make it better. You know, because I'm going to be honest, I'm not a Terraform expert. I mean, I've gotten so much better now since this project, but we can make things even better, right? Yeah.
I mean,
Now one thing you'll notice I have to do here. So I changed the values file, and I want to commit it. But what's going to happen is we ignore that because the workflow is checking in updates to the chart, so we don't want to get into an infinite loop. So what I'm going to do is I'm just going to go into my build push chart and delete a line.
And they said the cloud was just push a button, right?
Yep.
That easy. Yes.
Now I cheat because I have access directly to the repo, so I commit directly to the main branch.
It's always nice.
I would not get anything done if I could not
I agree.
get to the main branch
without I totally agree.
If I sat there and did PRs all day, it'd be
ridiculous. Yeah, no, it'd be ridiculous.
So that's actually going to go off and be running. So if we look at our actions, there we go. So that guy's going to go off and run. Come on. And like I said, it's going to go through and create all, because I made the change against the monolith repo. We have to build the UI front end Docker image, build the back end Docker image, build the Nginx image, and then once all those have been updated, we actually release the aggregate chart.
Whoa.
And then finally, when all that's done, we go and trigger the other repo to go and consolidate all the charts into a single one.
Is this GitHub Actions, or what is this called? Workflows or Actions?
They're called workflows.
Is this like a build tool, really?
Yeah.
Like it's really cool.
Yep, this is a good one to learn.
I think I'm gonna go and have a go. Yeah, I'd like to learn a bit. I've never used it actually, GitHub in this way. That's really cool. It looks really intuitive.
Yeah, it's you'll see in our repos. Whoops.
It's all just YAML based.
The way they work is you have a .github directory with a workflows folder, and then you have your YAML.
I just found the name workflows for me. It didn't register that it's actually a build tool. Just sort of threw me off a bit. But
it's confusing because on the UI here they call them actions, and then you get into it, and then they talk about workflows. It's like, all right, pick a name.
Okay. So you've cleared up that fog for me. Thanks, because I was actually a bit confused. What is work? I thought actions was separate to workflows. Yeah.
And then within a workflow you have jobs, and within jobs you have steps. So
sounds overly engineered again.
Nobody could agree on what's happening name wise. So like I said, after all this chugs along, it'll actually go over. It takes about 20 minutes to run. But the last thing it'll do is go ahead and trigger the workflow over here, and then this workflow will actually we can look at one of the past ones. It will go ahead and run the npm. and aggregate together all the latest versions from all the different repos of the charts. And from there, it'll create a new like consolidated parent-child chart with the latest versions out there. It'll actually commit it back to the repo, and then it'll run the chart releaser. And what the chart releaser does is basically the Helm package step that's wrapped up in an action. And it does a little bit more. It creates a release on the GitHub side. So this is where it's creating the release. And then it creates the index.yaml, gets it all checked in, and then kicks it off onto the GitHub pages side of things. Okay. So Sasha, you've definitely helped me forced me to clean up a bunch of stuff. I'm liking the way things are pulling together. So
yeah, I think it's great. I mean, if I could help in that way, I'm glad.
And what we'll need to do is we'll need to walk through the documentation that Tracy put together to make sure everything is working. We have all the commands in place.
Yeah, the thing is, you've kind of now got this micro testing environment, actually, with all these people from all around the world can micro test Ortelius for you on their local machines, and then you can get excellent feedback for your production, right?
Yep,
it's quite amazing.
Exactly.
Like you can have Utkarsh and Arvind and whoever else, yourself, can like break the rubbish out of it, try new things safely, right?
Oh yeah, exactly.
And it's actually a like for like environment. Okay, it's not the traffic, but at least it's the code, right?
Well, we can add the traffic, and that's part of what the documentation Tracy put together is how to integrate your CI/CD process into and hook it up with Ortelius. So you can actually start generating. So Arvind, do you have Jenkins running locally on your machine?
Yeah.
Yeah. So in your case, we can actually hook together your Jenkins and your local Ortelius, Arvind, and you can actually see the results inside of Ortelius of what you're doing on your Jenkins side.
Can't we like port forwarding it using the ngrok, and anyone can run it?
Yes, that is true too.
Yeah, actually, once Arvind, I want to integrate what Arvind's done into Ortelius in the box. You have Jenkins in there, and then you can actually run a full build, you know, like within your own environment.
Yep.
Which would be quite amazing to see.
Yeah. I think that's a great direction to head.
That was my idea.
I can try the same thing in Azure DevOps.
Oh, perfect. Yeah, I think, and I have the GitHub Actions piece done. So, I think if we take some of the stuff that Arvind's been working on and build upon it, and kind of take the same code base. So if it's like a Node.js or React that you're building, that Arvind's building, that we do the same build in Azure, GitHub Actions, and wherever else, and we kind of plumb it all together with a nice clean example.
Yeah, it'll be awesome, man. And it's totally doable.
Yeah, out of the application that I and Sasha are doing, we have completed the Java, Node, and React one.
Cool.
The Angular one is giving me some error, and then after we will try the Python one. Yeah. So these
I've got a Python one because I want to integrate PG admin for Ortelius in a box so that people can manage the Postgres if they want to, right? And that's a Python container, so that's a perfect one to use, right? Because it's actually going to be a usable piece. Yeah.
Oh yeah, I know exactly what you're talking about. Yeah, so that'd be very cool.
Two of the same thing, right? So you can manage a database through a GUI, but you can also deploy a Python container, which is nice.
Yep, definitely.
Yeah. And it comes with a Helm chart and everything, you know.
All right, that sounds like a good next step.
Because I already did it for work, so I already have the code.
Awesome.
That's very easy.
So let's keep going down and try to wrap up the Ortelius in the box. Get it to a point where we're happy with what it is, and then we can start adding on more features, like you said, for the PG admin website and some other, like the Jenkins next. But I think we should try to get just a clean Terraform to get us going.
And
then add on more bells and whistles to it.
Yeah. We start off with the core Ortelius, just deploying and getting access to that. Exactly.
Yeah. So I'll be around. So just if you run into anything, just send me a message on Discord.
I'm trying not to because it's your day off actually, and you're supposed to be eating turkey.
Well, turkey's gonna not till later tonight. So, and I'll be around in and out tomorrow. Anyways.
Okay. Cool, Steve.
All right. Thanks, everybody.
Cheers, man.
Cheers.
Cheers, Owen.
Yeah.
Go watch some soccer.
I'm definitely watching. I just see it's a draw now. 1-1.
There you go.
Cheers, bye.
Bye.
Happy weekend.